Afternoon, Chair.
Afternoon. Okay, mark your own attendance. Gerald, please mute yourself. Okay, today I'm going to cover the part on kinematic. So I'm going to talk about exercise 3E, okay? So in your SAT2, there will be one question on that. Okay. So can you please go to page 82?
Okay, hold on.
Okay, we are going to do question 4. Have you done it? Have you done question 4?
No.
Yeah. So can you please take a
Okay.
few minutes to find the velocity function? So you, by the help of your graphic calculator, so you first of all, you key in the function into your graphic calculator first. So every time when you do application question, what you need to do is use your GC. So let your GC help you. So your GC, that is what you're supposed to do with your GC. You key in your Y1 as this. And your Y2 as this. And your y3, if you want to, okay, please do that. Everyone should be able to know how to do all this already. Okay, after you key in, then you look at the answer of question 4, then you start to do, then you start to produce a sign diagram. So for part A, you have to differentiate the displacement to get the velocity. So you have to use the chain rule. Bring down the power, copy down the whole thing, power take away 1, time by the derivative of the inside. So you got negative 1 over 2 square root of t plus 1. So your unit of measurement will be meter per second. For kinematic, you must write down the unit of measurement. So your VT sign diagram, if you have a look at this, because the square root in front is a positive and here is a negative, so the velocity is always negative. Hello? Are you okay?
Yeah.
So if the velocity is always negative, what does that mean?
Below
It
the
is
x-axis.
slowing down.
Are you sure?
Oh wait, going back, going to the left from the
Yeah.
origin.
So you interpret this. The object is always moving to the left. Nothing to do with the origin. It can be at the left side or the right side of the origin. So does the particle stop? Does the particle stop?
No.
No. So the particle never stops, but you're always moving to the left. Okay, so now we want to find the acceleration. So the velocity function is negative half t plus 1 to the power negative half, correct? So we want to find acceleration with differentiate velocity. Bring down the power is negative half. Copy down the whole thing. Power take away 1. Time by the derivative of whatever inside. So it becomes 1 over 2 times 2 is 4. And this is power half means square root. Then after that, you cube it. If you want to write it like that. So you look at here, the top is positive, the bottom is also positive. So the acceleration sign diagram for this case, it will never become 0, correct? So it will be always positive. So what does that mean? If the acceleration is always positive, how do you interpret? How do you interpret?
Velocity is always increasing.
Yeah, the velocity is always increasing. So when we say the velocity always increasing, okay, moving to the left, yes, because the velocity is, the sign of the velocity sign diagram is negative. If velocity is negative, means the particle is moving to the left. Yeah, so you have to know what is the meaning of velocity. So that is how I interpret. So every sign diagram that I draw, I will always interpret. This is not because the question didn't ask me to do so, but I will do. Okay, so this question, you don't really need a graphic calculator to help you. One look, you know what is the sign. So you know pretty well, huh? Next time, please be on time. I will not take any late comer. Okay? One, twice, many times I will not take. Okay, so can we go to part B? Okay, they say find the initial condition. Okay, find the initial condition. When you say condition, when you have this word condition, right? You want to know the displacement, the velocity, and the acceleration. That is called initial condition. So that means you have to get your S0, you have to get the V0, and you have to get the A0. So all these you can use it using your graphic calculator. Yeah. So can you please go to your graphic calculator and get all the answer? You don't have to show your substitution. Do you get the answer? This one should be 3 meters. This one should be negative half meter per second. And this one should be 1/4. If you use your calculator, it will give you 0.25. So how are you going to describe? You will say initially, if you look at your book for the answer, the particle is 3 meters to the right. 3 meters to the right. What? Right of what? of O, origin.
Origin.
Yeah. Moving to the left at what speed?
Half meter.
Okay. With acceleration of 1/4 meter per second. Hello? Okay, now, can I? So, can I move on to part C?
Yep.
Okay, they want you to describe the motion of the particle after 3 seconds. So the word after 3 seconds also you talk about at 3 seconds. Understand? So you find S0, S3, sorry. If you don't want to find S3, it's fine because they want the motion of the particle. So we will find S3, V3, and A3. Okay. It's the same as saying condition. So may I know what is S3? Hello?
2,
S3 is 0.
2, 2, 2,
Mhm.
2, 2,
Okay. 0, huh?
2, 2, 2.
2 or 0?
2 is 2.
2. Okay. Okay, 2. 2 meter. The velocity?
Negative 0.25.
Negative 1/4.
Yeah.
Okay, acceleration?
0.03125.
1/8. 1/16. No, 32. 1/32. Is it? 1/32 meter per second square. Okay, so now, okay. Next time, whoever come in late for class, your attendance will be considered as absent. Huh? Okay, so we will say after 2 seconds, after 3 seconds, okay, it is 2 meter to the right of the origin. Okay, moving to the left at 1/4 meter per second with the acceleration of 1/32 meter per second. Okay, so you see, as you move to the left, because the acceleration is positive, the velocity is increasing. What happened to the speed?
Increasing.
Yes. So because of different sign, VT, the sign is always negative. AT, the sign is always positive, correct? So different sign that imply the speed is always decreasing. Are you okay? Hello?
Yeah.
Okay, now. So it never stops. So if I ask you to find the total distance traveled, it's quite easy, correct? Yeah. So now I want to put an extra question for this. Yeah, I want to put an extra question for this. Okay, I go to the next page. The displacement is this function. Sorry. Okay, if I add this question, find the time or find the range of time when the object is at the right of the origin. So what should I do for this case? How can I use my GC to help me? How can I use my GC to help me first?
You plot the graph,
Plot which graph?
y1.
Yes. So can you please plot y1 graph now? Because I talk about at the right of the origin. So you are talking about here, talking about displacement. I mean, mathematically, I'm talking about ST is greater than or equal to greater than 0. This is a mathematical statement. Yep. Then I find my T. So now use GC. How is your graph look like?
It starts like from the negative and then it slopes downwards.
Would
Start from the negative or positive.
Negative.
It start from 3. Because the initial position of the particle is 3. Isn't it? The initial position is 3 meters to the right. So you start from the 3. Then I think after that, it go down like that. The curve should be this way, I think. Should be this way. Am I right? Hello?
Yep.
Everyone got that? Then you have this value. You can find the x-intercept. This is 15. Am I right? Hello? Do you know how to get this value using your GC?
Yes.
You use second trace. You use second trace and find the x0. Right? Okay, so now what is the answer for this question then?
The first 15 seconds.
Yeah, so you say T from 0 to 15. Okay, may I know what is the value of S15 here? May I know what is the value of S15? Okay, someone have given me, thank you. Can I ask Kason, Cousin Chin, what is the value of S15?
I don't know.
Huh?
I'm not sure.
Cousin, how can you say you are not sure? Are you in the class, you tell me?
Not really.
You are not really in the class. So what are you doing? Can you tell me?
I'm eating lunch.
You are eating lunch. Do you think it's right to do that?
No.
No. If you are eating lunch, you look at the screen, you should know. Do you look at the screen?
At my side of.
You can't see my whiteboard.
I can.
So, do you see the graph of ST? So how do you read this point? How do you read the coordinate of this point?
Coordinate.
So you see, do you have the right to tell me you don't know? This is T. This is ST. So what is S15?
Oh, 0.
Who are you talking to?
You?
How come there is another voice there?
Oh, that's my sister's lecturer.
You all are at the same place.
Yeah.
You see, Cousin, you see, I just randomly pick. I can just ignore all this totally. But I really don't have the heart to do that. I want to make sure all my students are in the class and make sure you follow the class. Even you want to have lunch, you can have lunch, but please. Okay, so it's 0. Clear? So this is another extra question that they may ask. So they can ask you a lot of things. So you have to understand the question. Okay, can we go to question 6 now? This is another one. Can we try to solve question 6? And for part A, right, we will try to draw the sign diagram as well. We'll try to draw the sign diagram as well, okay? You can use your calculator to help you. Okay, so please, the ST function is this. I told you already, S82, I just set your question this morning. One question, the first question you see will be kinematic and it's 11 marks. So I don't wish any of my students to fail the test, but that is not beyond my control. Okay, so can you please find the velocity function, draw the sign diagram, even the question didn't ask you to do so.
Okay, sure.
Use your GC to help you. Use your GC to help you. So just change y1 to this, then you can work. Okay, so you differentiate. Use simple rule, you get 100. Then for E, you copy down the whole thing. Okay, look, if next time you have negative t over 5, correct? You view it as negative 1 over 5t. Or if you want to make your life a bit easier, you can change this to decimal, negative 0.2. Am I right? Yeah. Okay, so you can do that. So I have e to the power negative t over 5, then here times negative 0.2. Okay, then I use my calculator and times this up. $40, is it 40? 40, yeah? E to the power negative t over 5. Okay. So now is there a time whereby the velocity becomes 0? So this one, you can either use your calculator to help you, or you can your choice. So you can produce a sign diagram. I put 100 minus 40 e to the power negative t over 5 equal to 0. So my e to the power negative t over 5 is 100 divided by 40. Okay, so I have 2.5. Okay, or 5 over 2. Okay, I can put equal to 5 over 2. So my negative t over 5 equal to ln 5 over 2. So now, can t be negative? Can t be negative?
No.
Okay, so t must be greater than 0. So therefore, never stop. So sometimes you have to be very careful. It never stop. So if you plot this graph, I believe this graph, it go. Okay, I have to work it out. Yeah, so it never stop. Okay, so my VT sine diagram, how is it like? Is it always positive?
No.
No. That means it does
negative.
stop. It does stop. Wait, let me check. Ln 2.5. Always negative. Cannot be always negative. Always negative. Okay, I just simply put any value of t in. Is always positive or always negative? Hello?
It's positive.
Always positive, correct? I'm right, am I right?
Yeah.
Because some of you tell me is negative. Okay. So, but for this question, they just need this. this is our extra thing, okay? So bear in mind, okay, then we look for acceleration, okay? So acceleration, you differentiate the velocity here. Okay, so from here. Okay, you differentiate 100, you get 0, negative 40, e to the power negative t over 5 times negative 0.2. I told you already, put it like that, easier to see. So you get 4, you get 8 e to the power negative t over 5. So e to the power negative t over 5 is always greater than 0. So therefore, your AT sign diagram will be always positive. So that means the particle is always moving to the right and the velocity is always increasing. So in this case, is the reverse of the reverse, the velocity is the reverse of the previous. Correct or not? So now they say discuss the velocity of P. Okay, find the initial position, velocity, and acceleration for part B. Okay. So S0, what is the answer?
Hold on. I'm very slow to calculate.
Hey, what are you doing? 200 meter.
100.
Okay, what is V0?
Is it 59.9999999?
Huh?
Yeah, 60.
CM, sorry. Okay, what is A0?
8.
Okay, good. Now, part C. They say discuss the velocity of P as T approaches infinity. So we are going to discuss this as T approaches infinity. What happened to e to the power negative t over 5? Approaches? Approaches?
Zero.
Which is 0.
Zero.
Yeah, approaches 0. Yeah. So what happened to negative 40 e to the power of negative t over 5?
Approaches 0.
So what happened to your VT, which is 100 minus 0? Approaches?
100.
100. From below or from above? This is the upper limit or the lower limit?
From above.
Look carefully. It's 100 minus something. Is this an upper limit or the lower limit? Is the upper limit of VT or lower limit?
Upper limit.
Upper limit. If it's the upper limit, I mean this is the highest, am I right? So the rest of the VT, that means my VT is always less than 100. So here I have to put below or above. The whole graph of VT is below 100 or above 100. So I have to say from below. Are you okay? So that means the velocity will not go beyond 100. That is the interpretation. Okay, can we go to D? Can we go to part D? Sketch the graph of the velocity function. Okay, can you please sketch the graph of the velocity function? Initial velocity start from 60. It always go up. Upper limit is 100. So when you sketch, you make sure you get all these right. So I believe the graph go like that. Am I right? So if I give you, I ask you to sketch the graph, I give you 2 marks. I will look for this and look for the shape. If you didn't give me the limiting value, then I will not award you with the mark. Are you okay?
Yep.
So in this case, if I want to find the time when the velocity is 80, so 80 is here. I can use 2 methods. I can put my y4 as 80, then I find the intersection point, right? Or if I don't want, I can solve algebraically by letting the velocity equal to 80. Equal to 100 minus 40 e to the power negative t over 5. Okay, so 40 e to the power negative t over 5 is equal to 20. So e to the power negative t over 5 is equal to 0.5. So my negative t over 5 equal to ln 0.5. Yeah, so the exact value, this is, okay. If they didn't ask for exact value, it's fine. You just use your calculator and get the answer. If the question asks for exact value of the time, then this method will be not good. Okay, so how will I do it? I will do it this way. If the question asks for exact, I will write this as 1/2. So the negative power for e, I will write it like that. Then I will say e to the power of t over 5 equal to 2. So my t over 5 equal to ln 2. So my t will be 5 ln 2. Are you okay? If they ask for exact value, then this should be the exact value. Are you clear? If not, you can just use your GC to help you to do. So I show this working is for the exact value. Okay? So now, I'm going to do some differentiation on the certain function to let you know certain thing is very important. When I say very important means I will ask you in your, okay, if I have the displacement function as this, if I have my displacement function as this, okay, if I want to find the velocity function, what should I do? What rule should I use?
Correct.
Product rule.
Yes. So remember, I told you already, the number outside, just leave it outside here. So your U is T, your V is A. So try not to use U and V. Why? Because we are dealing with velocity. So try not to confuse ourselves. So we use P and Q. So P prime will be 1, Q prime will be -4 e to the power of -40. Okay, so I put in V, Q, P prime plus P, Q prime. Right? So after that, you factorize out the common factor. Am I right? Okay. So to draw the sign diagram of this, every one of us should know this. Am I right? Did I ask you to write this function? Still remember the function I asked you to write? Hello? Did you write down this curve? Draw out this curve? In your one-page handwritten notes, have you wait until next week only you start preparing, okay, go ahead, you fail your test, don't come and blame me, okay? You have this? So if I want to draw the sign diagram of this, is it easy? Yes. After I differentiate it, I can straight away get my sign diagram. And here I know is 1 over B. Our B here is 4. So it's 1 over 4. So I put here 1 over 4, you see? Plus, minus, done. So how well you prepare this is your choice, okay? Then now, if I want to get the acceleration function, what I will do, in this case, my P will be e to the power -40. My Q will be 1 minus 40. So I differentiate. And here I differentiate. So then I put in. Then still there. Open bracket. Okay. Q P prime plus Q prime P. So use products rule all the way through. Common factor, -4 e to the power of -4. So take out -4 times 10, -40 e to the power of -40. Close. 1 minus 40, take out 80 plus 1. So I have -40, 4 e to the power of 40, 2 minus 40. So this is the inflection point. So I have my AT will be 0. Here is 2 over B, so it's half. concave, convex. See or not? So I can put any function in I1. So I can put the search function as one of your question in your kinematic, or I can put the search function in the question on rate of change. So this is a very important function. Clear?
Yes.
So in this case, what can you say about the displacement of the particle? Where is the particle all the time? At the beginning, the particle is at the origin. After that, where is the particle?
To the left, right? No,
Where is the particle?
to the right, to the right.
The particle is always at the right of the origin. What feature of the graph tell you so? Which feature of the graph of ST tell you so? If I ask you to sketch a graph of ST,
The y-axis, right?
yeah, it's always above the x-axis, so the ST is always positive. So the ST sign diagram for here, the ST sign diagram will be like that. Always positive, never become negative. Hello? Are you okay?
Yep.
So the feature of the search function, it can appear in both kinematic or rate of change. So it depends on my selection, up to me to select. Are you okay? So can I assume I have completed the static kinematic part? There are some other questions. You please go and do it by yourself. Okay, and you have review to do also. Yeah. Okay. Any other questions? Okay. So for tutorial, I will try my best to explain optimization question. Then lecture, I will talk about rate of change. Because optimization question, the difficult part is forming the formula. There are a few questions I believe you will need my help to form the formula. So I will discuss all the questions in tutorial. Are you okay? Any more questions? No more. Okay, thank you, class.
Thank you, Miss Do.
Thank you,
Mm.
Miss.
Thank you, Miss.
Thank you.
Thank you.
Thank you, miss.